Hi, I'm back. So I just realized that if I get a phone call while I'm recording, it stops recording. So I'm not sure where I left off on this problem, but I wanted to point out that I have one real zero and I have two non-real zeros with the plus or minus I rad 5, and I have two real zeros with the plus or minus the square root of 3. There's no I here. This is just a decimal. So now I'm ready to do number 11. This guy is the difference of two cubes because 8x cubed is just 2x cubed, and then 1 is just 1 cubed. So I'm ready to write it into my formula. So I write what I see, 2x minus 1. Since my minus has been used already in my binomial, that I know that my trinomial just has two positives. So I'm going to get ready and do my square, product, and square. So 2x squared is 2x squared would be 4x squared. Their product would be 2x, and then 1 squared is 1. So now I set each of my factors equal to 0. And so my 2x minus 1 equal to 0 would give me 2x equals 1, x equals 1/2. This is one real root. This problem right here is not factorable. There's nothing that's going to multiply to 4 by adding to 2. So you could complete the square. I wouldn't, because after dividing everything by 4, my b would be a fraction. I have to divide by 2 again. I have to square it. So this is something that I would use the quadratic formula for. So my a is 4, my b is 2, and my c is 1. So my x would be equal to, it's negative b, so negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a, which is 4, times c, which is 1, all over 2 times a, which is 2 times 4. So simplifying this guy up a little bit, I get negative 2 plus or minus. Inside here, I get 4 minus 16, so it looks like I'm going to get a negative 12 over 8. And so the negative 12 I can simplify. This guy is really 4 times 3. And 4 is a perfect square. So I can write this as negative 2 plus or minus. Sorry, that doesn't look like a negative 2. If I pull the negative out, that's an I. And if I pull the 4 out, it's a 2, because the square root of 4 is 2, and that leaves a 3 on the inside. I can continue simplifying this by writing my negative 2 over 8 plus or minus 2I rad 3 over 8. And those simplify. It'd be negative 1/4 plus or minus the 2 and the 8 would cancel to 1/4 again. So it'd be I rad 3 over 4. This is two non-real roots. I would have negative 1/4 plus I rad 3 over 4, and I'd have negative 1/4 minus I rad 3 over 4. This would be my two non-real roots, my one real root, or my three roots for my third degree polynomial. So the next problem, the next two problems, both 12 and 13, use the rational root theorem. I'm going to go ahead and do 13 with you to check this one out. So for this problem, I would use my Q, which is 2, because remember the queen comes before the princess, and my negative 20, which is P, to help me figure out my possible roots. So if P is negative 20, then my possible factors of that would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 10, and plus or minus 20. Oh, and I forgot plus or minus 5. Can we insert him right now? So then my Q, which is 2, its factors be plus or minus 1 and plus or minus 2. So this looks like it might give me lots of possible real roots. So I'm going to take each p divided by each q. So when I take each one of my p's divided by 1, I just get them back. So I get plus or minus 1, plus or minus 2, plus or minus 4, insert my plus or minus 5, plus or minus 10, and finally, wow, plus or minus 20. Then when I take each of these terms divided by 2, it only adds a couple new possible roots. So for example, 1 divided by 2 would give me also plus or minus 1/2. 2 divided by 2 is my 1. 4 divided by 2 is already here, it's 2. 5 divided by 2, that would be new, plus or minus 5 halves. 10 divided by 2 would be my 5 right here, and 20 divided by 2 would be my 10 right here. So it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, double them for the plus minus, 16 possible roots. So I told you in class to use -2. This is because if you try a 1 with synthetic division, you have a remainder. If you try a -1, you have a remainder. If you try a +2, you'll have a remainder. So the first real root that would work is going to be -2. So I write my 2, my -17. This would be a -32x when I bring it over, so -32. That would have been a +20 when I bring it over, so then this would be 20. And so now I get ready to do my synthetic division. I bring down the 2, and I multiply and get -4. This then gives me a -21. I multiply by -2, and I get positive, what, 42? And then I add them, and I get 10. And then I multiply by -2 and I get -20, and I get 0 as a remainder. So this tells me that -2 is a root. That means that x plus 2 was a factor, and so is, now I use my new coefficients. I go 1 degree less, which is x squared, and I get 2x squared minus 21x plus 10. So at this point, this is actually factorable. So I'm not going to use the quadratic formula. If you didn't realize that, or you didn't want to try factoring it, you could put 2, -21, and 10 into the quadratic formula. However, this would give me x equals -2. I'm going to attempt to factor this then. So the way we've been doing it in class with the diamond method, I have a 20 on top and a 21 on the bottom. Usually when they're only one apart, it's going to be the number, the 20 and the 1. And in this case, to get a -21 when I add them, they're both negative. This will give me a positive 20 when I multiply them. Because my a is 2, I need to now bring it into factor by grouping. And so I have 2x squared minus 20x minus 1x plus 10. Now I group them, and I would have a 2x here, and I would get x minus 10. And here, in order to get x minus 10, I'd have to pull out a -1 to get a positive x and a -10. So now since these match, I'm going to pull out x minus 10, and I'm going to have a 2x minus 1 left over. So I'm going to bring down actually this x plus 2, just so you guys can see that in fully factored form, it's x plus 2, x minus 1, and 2x minus 1. And as you saw right here, this x plus 2 gives me an x equals -2, so that's one of my roots. This gives me x equals positive 1, that's another real root. And this would give me, when I set it equal to 0, I would add the 1 over, and then I would divide by the 2, and I get x equals 1/2. These would be my 3 real roots for my third degree equation. Number 12 is very similar. You have to use the rational root theorem. I told you in class to use -4. And then when you're solving it, you'll have to end up using, actually, I'll do this one only because I want to complete the square, just to kind of remind you how to do that. So this one, I told you in class that one of the roots that would work would be -4. So I have my 1, my -2, my -25, and my -4. And so I bring down my 1, and I get -4. I get -6. I multiply, and I get positive 24. I get -1. I get a positive 4, and my remainder of 0. So this tells me that x plus 4 is the factor, and this tells me that x squared minus 6x minus 1 is also a factor. This, unlike number 13, does not factor. Your choices are to complete the square or use quadratic formula. For me, since my a is a 1 and my b is even, I would complete the square. So to complete the square to solve this, I have my x squared minus 6x minus 1 equals 0. I'm going to move my 1 over. I have x squared minus 6x equals a positive 1. So now I do my b divided by 2 and I square it. So I get -3 squared, or 9. This is the number I add to both sides. And so on the left side, this factors into x minus 3, it's my middle step, squared, equals 10. So now I'm going to take the square root of both sides. I get x minus 3 on the left, and on the right I get plus or minus rad 10. I go ahead and add my 3 over, and x equals 3 plus or minus the square root of 10. This is 2 real roots. It's just a decimal. It's 3 plus whatever you get on your calculator for the square root of 10, and it's 3 minus whatever you get on your calculator for the square root of 10. So 2 of my roots are 3 plus or minus the square root of 10, and they're 2 real roots. And my x plus 4 would give me x equals negative 4. And so this would be my third root. 1, 2, 3 roots for my third degree polynomial. Number 14 is very much like number 10. You just have to remember to do your GCF first. I found it to have a GCF of positive 3x squared. And so once you pull out a 3x squared, you'll have x squared minus 3x minus 28 equals 0. And so this factors, you'll end up getting a 7 and a negative 4 when you solve this. And when I set this equal to 0, I get x equals 0. But remember, it will have a multiplicity of 2 because your x was squared there. So what's going on the back page? So on this page, you were asked to list all the zeros, find the y-intercept, describe the end behavior, and make a possible sketch. So this does not factor. So I am going to think about what my possible real roots. In class, I told you to use 1 and negative 2, but if you didn't know that, your q is 2 and your p is negative 8. My factors of my q would be plus or minus 1, plus or minus 2, and my factors of my negative 8 would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And so you can see in the locker on the answer key all of my possible roots. Of those possible roots, I asked you to try 1 and negative 2. So when you try 1 on this, you would have your 2, your 11, your 9, your negative 14, your negative 8. And when I do my synthetic division, I bring down my 2, I would get 2, I get 13, I multiply, I have 13, I get 22, I multiply, I have 22, I get what, 8? And I multiply and I get 8, gives me a remainder of 0. So this tells me that x minus 1 is a factor, and so is then 2x going down 1 degree from 4, 2x cubed plus 22x squared, 13x squared plus 22x plus 8. You would use synthetic division one more time with negative 2. And I'm going to let you guys look in the locker to double check that work, just to kind of help hurry this review along for you. So when you get all the way done, you get f of x equals, and so you'll have your x minus 1, x plus 2, because the negative 2 will work, it'll give me an x plus 2. And from your synthetic division, you will also get 2x squared plus 9x plus 4. So this I can factor again. So when I use my diamond method, on top I would have an 8x squared, and on the bottom I would have a 9. So I'm trying to think of 9x. I'm trying to think of two things that multiply to 8 while adding to 9. So since they're 1 apart, I'm going to use the actual number 8 and 1. So 8x and 1x, they both need to be positive because they multiply to positive and they add to a positive. So remember, because the a is 2, you have to use factor by grouping. You have 2x squared plus 8x plus x plus 4. And when you group them and you pull out an x squared, 2x squared, you would get, or 2x, sorry about that, I'm getting ahead of myself. You would get x plus 4 left over, and here you already have an x plus 4, so let's just take out a 1. So this gives me, when I take out my x plus 4, it gives me a 2x plus 1. And I already had up above an x plus 2, and I already had up above an x minus 1. So this is my polynomial fully factored. And these factors give me 4 real roots. My 4 real roots are x equals 1, x equals -1, x equals -4, and then I would get x equals a -1/2. So now I'm going to go mark those x-intercepts on my graph. Those are also the answers to A. So let me write that in. So x equals -2, -1/2. What was there? A 1. What am I forgetting? A -4. So on my graph, I'm going to take a moment. I'm going to mark x equals 1. I'm going to mark x equals -2. I'm going to mark x equals -4. I'm going to mark x equals -1/2 right there. So next thing I need is my y-intercept. The y-intercept is what I get when I substitute in a 0 for x. So since this is in standard form, I know my y-intercept is going to be 0, -8. Because when I plug a 0 in for each of these x's, all the other terms disappear and I have a -8. My end behavior. This is a 4th degree polynomial and my coefficient is positive. So I know my end behavior would be up on both sides. So I know I go through 0, -8, 1, 2, 3, 4, 5, 6, 7, 8. It's really hard for me to see because there's no lines on this copy or a printed copy of a copy. So now I'm ready to sketch this. So I sketch right to left, but you can sketch left to right. It makes no difference. I'm going to come down through my 0 because there's no multiplicity, no bounce, nothing fancy going on. I'm going to come up through my y-intercept, just pick a turning point and use it. I'm going to come up through my next x-intercept. I'm going to pick a turning point and turn around and come back down. And then I'm going to come down. I'm going to have a turning point. I'm going to come back up and go through it and put arrows on my ends. So, and then this would be my sketch of that problem. So, taking a look at these guys, according to the rational root theorem, x equals 1/3 is a possible root. Just like I've been doing on all the other problems we were working on, I would look at my Q because the queen comes before the princess. I would list my roots, my factors. My factors would be +or-1 and +or-3 for P. My factors of Q would give me a +or-1 and also a +or-3. So my possible roots then are my P divided by Q. So 1 and 3 divided by 1 would just give me back roots of +or-1 and +or-3. And then 1 divided by 3 would also give me a +or-1/3. And 3 divided by 3, I'd be back at my 1. So these are my 6 possible roots. So yes, +1/3 is one of my possible roots. So this guy would be true. It says if P of 2 equals 0, then x plus 2 is a factor. So no, this is not true, because if P of 2 equals 0, that's telling me that when I substitute 2 into my polynomial for all my x's, I get a 0 for my answer. It's also telling me, because of the remainder theorem, that if I do synthetic division on this polynomial with a root of x equals 2, I'm going to get 0 as my remainder. Therefore, x minus 2 is my factor. X equals 2 is my root. So this is false. It would be x minus 2 that would actually be my factor. So the function x squared minus x squared times x minus 3 squared times x plus 1, there's a bounce at x equals -1. This is also false. There's a bounce when I have a positive even multiplicity, or an even multiplicity. So there's actually a bounce at my x equals 0 has a multiplicity of 2. My x equals 3 also has a multiplicity of 2. But my x equals -1 is just a simple 0. The graph will just go through at that point because it has an exponent of 1. A cubic function will have the roots 2, 4, and 3i. This is also false, because I know from class that my complex or my imaginary roots, my non-real roots, always come in pairs. So 3i by itself cannot be one of my roots. It would have to be a plus or minus 3i. So this then, if that was the case, this would be a 4th degree function that could have the roots 2, 4, and plus or minus 3i. So in behavior, it says that the in behavior of p of x equals x cubed times x plus 2 is the same as r of x, which is x squared times x squared plus 2. So when I look at this one, this problem, when I add my exponents, I get a 4. So this is degree 4. And if you multiply these two out, your highest exponent would be an x to the 4th. This problem, when I multiply these two guys out, I also would get my highest exponent would be an x to the 4th. This would be also degree 4. So be careful when you look at those. So yes, these both have degree 4. They both have a positive leading coefficient of positive 1. So my in behavior would be up and up. This then would be review 2 for our Unit 4 polynomial test. Thank you so much.